How do you build a 470-meter rig in 300 meters of water? How is it fixed to the seabed without moving? This video will take you to the secret of this 700,000 tons of TRO gas platform. The platform is located in the North Sea, 70 kilometers off the coast of Norway. The waves there can reach up to 30 meters. So to get the huge platform to stand on its feet here, the designers had to face difficulties that can be imagined. You'll be wondering at this point, how was the concrete poured in the deep sea? In fact, the pillars of the platform were towed 300 kilometers away from the platform. After the whole construction was completed, it was towed here, so it became the tallest and heaviest movable structure in the world. Because the pillars at the bottom of the platform will be 300 meters deep into the sea, the pressure of the seawater there can reach about 40 kg per square centimeter. Therefore, it is necessary to ensure that the pillars are strong and at the same time, the pillars must not have the slightest flaw or crack. The designers calculated the thickness of the bottom pillar, increased to 2 meters, and in order to prevent cracks during the pouring process, they used a special mold. The concrete was poured continuously 24 hours a day. The molds are hydraulically raised and the concrete poured are added with some special additives, which allows the concrete to set quickly. This method is known as the Wammeling method, and is currently the fastest method of pouring large concrete building is the fastest method. Even so, it took them a year to build the pillars of the lot platform. It took them a year. After a year, the 300-meter high pillar was finally built. Now the engineers are ready to assemble the pillars and the platform together. They first filled the hollow pillars with water. The pillar was sunk into the water. Then the suspended platform will be moved to the top of the pillar, and then the water inside the pillar will be drained. Then the platform can be lifted up. Finally, the 656,000-ton platform was towed by tugboat to the 70 kilometers away from the worksite. In order to withstand the pressure of 300 meters of seawater, they used slip forming to make the pillars to be built without any cracks. These pillars will keep the platform standing for 100 years. To build these 4 huge pillars alone, used as much steel as 15 Eiffel Towers. Because the pillars are hollow and extend up to 300 meters above the seabed, the hollow pillars are also equipped with an elevator inside. If you take the elevator from the top of the platform, it would take 10 minutes to reach the top of the pillar. Now here is the bottom of the pillar. That is, at a depth of 300 meters above the seabed. The pressure of the seawater here is 380 tons per square meter. Although the platform can withstand the enormous pressure of the ocean depths, but its structure still has unseen dangers. This danger was a nightmare for the engineers. November 7, 1940, the suspension bridge over the Tacoma Channel in the United States collapsed with a bang. The cause was the resonance of the wind blowing over the bridge. This was also fatal for the lot platform, as the waves would constantly beat against the platform struts. Once the frequency of this beating formed a certain direction and rhythm and reach the zero ring of the pillar, the platform may end up like the Tacoma Channel suspension bridge, like the end of that. So the engineers took this issue very seriously. Reduce the threat of resonance of the platform pillars. They installed a huge concrete block in the middle of the pillars to reduce the frequency of pillar resonance. This greatly reduces the risk of platform resonance. Although the height of the platform is 450 meters, the weight of the water-filled flour can reach more than 1 million tons. Even so, it cannot stand on the seabed stably, so the engineers used suction piles to hold the platform firmly on the seabed. Here is an experiment. You will understand the principle. This transparent tube is like a suction device on the bottom of the platform. Only the suction device of the platform will be much larger than this, but the principle is the same. At the top of the tube is sealed and equipped with a valve, and then use a large bucket of mud to simulate the seabed. Then the tube is pressed hard into the mud, but because the tube is sealed, there will be a lot of air compressed inside, so it is difficult to press it down. But when the valve at the top of the tube was opened, after the air inside is removed, it is easy to press the tube down, then turn off the valve, and then try to pull out the tube is almost impossible because he has been tightly sucked in the seabed. This is also the principle of suction piles. This suction pile platform has a total of 19. The height of each one is close to 40 meters. They fix the platform firmly on the seabed. Even if there are 30 meters high waves, cannot move the platform. This also makes the Tello platform a modern project. This is the end of the video. If you like this kind of video, remember to give attention to it. See you next time.